Hello everyone, good evening. My name is Dominus Orbis, and today I'll be doing Packet Tracer 7.3.2.8, configuring GRE over IPsec. The important thing to remember here is that GRE is just the generic routing encapsulation protocol, which can pretty much transport any kind of layer 3 packet over the public internet. Now, one of the downsides, and I've already talked about this in the configuring GRE packet tracer, is that in fact it is unencrypted. So, in order to make that data more secure, we're going to use IPsec. Let's look at our task here. This packet tracer feeds you all the commands, so don't worry. Verify you are the network administrator for a company which wants to set up a GRE tunnel over IP secure to remote offices. All networks are locally configured. You'll need the tunnel and encryption configured. Ping R2 and R3 from R1. Well, they're not labeled. That's okay. That's R2, so this must be R1. No. Okay, I can ping R1. That's myself, of course. I can ping R2. And I can ping R3. We must have some default routes here. Let's look. There they are. Okay. Attempt to ping the IP address of the server 1 from L2. Repeat this after configuring the GRE tunnel. This is not going to go through. Ping PC3. These things are not labeled. It seems like in Cisco 4, CCNA 4 that is, the lab's quality deteriorate. Lots of errors. Shouldn't be able to get through. Let's see. And there goes. Okay. Why? Because we haven't set up the tunneling. And there is no routing protocol. Alright. We need to activate the security technology package on the routers. Router 1, Router 2, and Router 3. All three. It's just going to go in order. Router 1. accept the EULA, do a copy run, do a reload. Wash, rinse, repeat. License, boot, module, model number of the router, technology package, security, accept the terms of service, do write, do reload, yes. Okay. Now we're going to identify the interesting traffic on R1, or in other words, we're going to configure an ACL, which will permit all traffic on the 10.0.0/24 network which will be here. Okay, we're going to permit all that traffic to the server. Let's continue reading. See, interesting traffic actually triggers the IPsec VPN to be implemented only whenever there's traffic between R1 and R2 and R3 lands keyword. All other traffic from internet or anywhere else will not be encrypted. Where am I going? Oh, to laptop 2 and PC 3. So, laptop 2 and PC 3. The access list has summarized those subnets. Diffie-Hellman group here. set up my key, pre-shared. I went into quite a bit of detail in the configuring IPsec packet tracer, so go back and look at all those acronyms, what these encryption protocols are, transport, key management, data integrity, etc. You can see what all this means. Won't go into detail with it now. Phase 1 is creating the encryption and binding it to the access list. Also creating the authentication to be pre-shared using AES encryption. And then creating a key for each one of my peers. Step 2, or phase 2 that is setting the transform set. Let's do that. Now I'm going to create a map for that traffic. It does exactly what it sounds like. Mapping it to that ACL I created. I'm going to set my peers that will be allowed to access my packets. Match it to my ACL. We're done there. Now assign that map to the physical interface on the router where the traffic will be exiting. There we go. Looks good. There's no encryption between router 2 and router 3. From here to here. So keep that in mind as we're configuring. Repeat steps. Who is my peer for R2? It's going to be R1. Set the transform set. Create a map. Bind it to my ACL. Set my peer on my map. Match it with my ACL. There we go. Let's bind the map to my physical interface. Oh, I have a typo here. Moving on to router 3. My R3 peer will be R1 again. Create a crypto map. Bind it to my ACL. Set my peer. Match it to my ACL. Bind the map to the physical interface. Okay, now let's create a tunnel. A GRE tunnel. Tunnel source, tunnel destination. Save yourself some typing. There we go. Packet Tracer only offers one mode, which is IP. Oh, I'm sorry. GRE and IPv6. But over GRE, only IP. Even though, according to Netcat itself, it can encapsulate any layer 3 protocol. But we're going to go ahead and configure that. Now we need to go to R3 and do the same thing. Just change the addresses a little bit. Set physical interface of router 1. I don't even think we get any points for configuring the tunnel mode, but let's see. One little step I missed. On R1 it has two tunnels, one to R2 and one to R3. That's where reading instructions comes in handy. There we go. And that's one going to R3 right here. Oh, sorry, it's a physical interface of R3. There we go. Already did R3, now do R2. We're almost done with this packet tracer. Now let's configure a couple of routes. We'll be done. Looks like we got to do a little bit of route summary. There's my route. What was it? /21. It's going to be a 248. No, I think I have to create 2 routes on router 1. We don't have to summarize. Here's the next top right here. That should do it. Yeah. And then the same thing to router 3. The next hop will be what? Right here, the tunnel. There we go. Now we need to create routes on router 2 and router 3. Both to the tunnel interface here of router 1 So for router 2, it's the .1. There we go. It would be .2 for router 3. Sorry, the .5. There we go. Alright, what else we got? Seems like I missed a step. How's my ACL incorrect? I think this is one of the broken ones. Let me look at something. Okay, upon closer consideration, the packet tracer is not actually broken. This time I made a mistake, and I'm routing traffic right here on R1 for the 16.0 right here to router 2. I don't have a access listed as permitting traffic from router 3. So let's go ahead and do that. There we go. Alright, router 1's done. Router 2. There we go. It helps if you can do those wildcards in your head. And I have a hard time doing that. And that's why I made the mistake. But that's okay. That's why it's recommended when you write your access list, you write it in a text editor first. what was it? /8. Done. Let's go back to laptop 2. And ping the server. Let's see if we get through. Oh wait, is that even the server? No, it's not. From PC3, also ping the server. There we go. Alright, getting through from laptop 2 to the server. Laptop to the server, over the tunnel. Same thing for PC3. Gonna ping the server. Getting through from PC3. Of L2 from PC3. Remember, there's no tunnel between router 2 and router 3. So these packets should not go through. And it's failing. We don't have a tunnel here. So, once again, I am Dominus Orvis. I hope this video has been informative, and I want to thank you for viewing.